My name is Demian. I work at Google. I am a mobile solutions engineer, which means that I work with many companies on projects around progressive web apps. Today, we are going to talk about advanced caching strategies. We are going to go from the basic to the advanced, so hopefully this is going to be good for everyone, even if you are not aware of many of the details around PWA. And just to start, for those that don't know much about what PWA is, this diagram here is showing the main component of PWA, which is the service worker. Service workers are just JavaScript files, but it's a very special type of JavaScript file. It's a type of web worker, which means that all the code that you are going to use in the service worker is going to run in a different context from the page. And in the service worker, you're going to be defining different events. So in each of these events, you're going to do different things. For example, in the fetch event, which is the one that we are going to talk about today, what you can do is to intercept requests from the page and make a decision. So then you can decide, for example, I'm going to respond from the network, or I'm going to respond from the cache. You can do many things with service workers, so you can even download the entire website if you want and serve it offline completely. You might not want to do that, but you can do it, so it's very powerful. And good news is that service workers today are adopted by all the major browsers. This doesn't mean that all the features in the service workers are available. So push notifications, for example, are not available in Safari. And actually are not available in WebKit because any browser that's running in iOS, for example, is actually a wrapper of WebKit. Until WebKit provides this functionality, you are not going to be able to use it in this platform. But in the rest, in Android, is widely available all the features. The features we are going to see today, which is about caching, these are supported across iOS, Android, and any other device. And it's not only browser support that has changed, but also the tooling and the libraries around service workers. So in the past, if you wanted to build a PWA, you needed to write all the code for the service worker manually. So it would be something similar to what you are seeing at my right-hand side. This code you are seeing there is just for one caching strategy. So today we are going to talk about caching strategies. And if you want to do the same thing with Warbox, you are only going to use 5 lines of code. So the first recommendation that I have today is don't reinvent the wheel. Service workers have been out there for a while now. So these tools help to speed up development, and they encapsulate a lot of best practices around PWA. So take advantage of them. Once you write the code for the service worker and you ship that, your page is going to run a snippet of code to register this service worker, and it's going to go through different stages. So this is the diagram of the life cycle of a service worker. The first one is the installation step, then you have the activation, and then after that, the running state. During the installation, what you are going to do is to cache all the resources that are like the shell of your site. So you can think about that step like if you were installing a native app. So all the files that you are going to be caching in that step are the version of your site. Could be JavaScript, CSS, icons, all the critical resources for your web app. We call that pre-caching because you are actually caching things before they are requested. So this is pre-caching. When you move into the runtime state, you are going to start receiving requests from the page, and you can choose to respond to them differently. For example, you can say, I'm going to respond to images by always going to the network, and when I have them available in the cache, from now on, always from the cache. This is a runtime caching strategy, okay? Pros and cons of each approach. So pre-caching is, as I was saying, similar to installing a package. So it's very easy to keep all the files that are the version of your website on sync. And it's a good solution for critical resources. The problem with pre-caching is that you are making an assumption. So you are making an arbitrary decision. I'm going to say that all these files are likely going to be used by the user at some point, but you don't really know. So the thing is, you have to be careful. You have to be careful because you can actually end up downloading a lot of things that the user is never going to use. Precaching with Warbox looks more or less like this, but this is like a short version of that. So how it works, you are going to tell Warbox to precache a list of files, or you can say, you can take this folder and you can precache all the content of this folder. And this is the part of the service worker that Warbox is going to generate automatically for you. So every time you run the build process, if any of these files change, a new service worker is going to be created and it's going to be pushed to the client. So the old version of the file can be removed and the new one can be brought from the network again. So every time you push a new service worker, think about the same thing as when you push a new version of a native app to the store. And you start downloading some things and you start cleaning up others. So this is actually more or less that step. Runtime caching, we said, is great for non-critical assets. So for example, most of you guys come from the e-commerce world. If I go to a product page and I have to see the hero image, that's actually an asset that's not critical. It's not part of the version of my site. So there you can apply a runtime caching strategy. The problem with this is that the first request that comes from the user is going to go to the network because you are not pre-caching this file. So the first request is not going to be affected by the caching strategies. And the other problem is that the cache can grow over time. In this case, you don't know in advance how many files you're going to be caching, so you have to be careful. There are ways when you can specify the age of the cache, or you can set the number of resources to cache. But you have to be careful because if you have a user that's visiting 1,000 products and you are saying, I'm going to cache all the images, you are going to end up having a very, very heavy web app in the phone of the user. This is how a typical runtime caching strategy looks like with Warbox. It's very simple to do. So what you are going to have first is you are going to register a root. What you are saying there is any URL that comes with the images subpath, I'm going to apply this caching strategy. And in this case, the strategy is called cache first. Cache first means I'm going to the network, I'm going to store the response in the cache, and from now on, I'm always going to be responding from the cache. You can also apply expiration by number of entries or age, so this is pretty flexible. And you have many caching strategies. This is just one of them. So when you have a very basic baseline PWA, your website is going to be a combination of pre-caching and runtime caching. So in this case, this is just a blog, for example. The icons, the functionality for the search bar, the navigation bar, CSS, JavaScript that controls like the shell of your site, pre-caching. And then the images, for example, for the articles are going to be runtime cache. Okay? When we talk with companies about service worker caching and we present these things, the number one question we receive usually is how this is different from HTTP headers, which have been forever in the web for a while. And there are very important differences. So the first one is that with service worker caching, you can skip the network entirely if you want. So you can even, as I was saying before, download the whole app to the phone of the user and never go to the network. This is something that you can't do with caching headers. Another thing is that you can apply very complex strategies. For example, you can say, for this pattern of URLs, what I'm going to do is I'm going to go to the network, I'm going to store this in the cache, I'm going to return the response very fast to the user from the cache and update the network, the cache simultaneously from the network. So these things usually you can't really do with HTTP caching headers, which are fairly limited. And finally, when you are storing the JavaScript in a service worker caching world, it's actually the bytecode representation of that JavaScript, which means that if you need to execute the script, it's likely going to be faster than when you don't have it precompiled. Costs of service worker caching. So if you think about the diagram we saw before, you now have a new layer of JavaScript between your page and the network. In some cases, if a user don't visit your site very often, that service worker needs to be reactivated, and that might take some time. So that's one of the problems. Another one is that in some phones, for example, very low-end devices, the cache reads sometimes can be slow, and that's a problem as well. Another thing is that if you pre-cache aggressively, remember that the service worker is going to run in a different thread, but it's going to share the same bandwidth with the page. So you don't want to deprive the page from the bandwidth when you are pre-caching. All these things have solutions. Okay? You can do, for example, navigation preload, and you don't need to wait for the service worker to wake up. You can send directly the request to the network, and when the service worker is activated, you can continue serving from there. Or, for example, you can always register the service worker in the load event of the page. So you wait for all the resources to be requested by a page, and then you run the pre-caching part. So these things are not complicated to solve, but it's good to keep them in mind anyways. And so far, we talked mostly about one type of request, which are resource requests. This is JavaScript, CSS, images. We talked about icons. But there's another type of request in every website. And these are navigation requests, which are basically requests for full web pages. Interestingly, when we reach to a point that a company is building a PWA, they usually are very good by caching resource requests, but they don't think about caching navigation requests. And if you want to keep something in mind from today's talk, navigation requests are actually where the biggest performance gains can be made in a progressible app. Why? Because if you think about it, if you can, for example, anticipate what the user is going to do next, have that page already in the cache, by the time the user clicks on that page, you have it already there. It's going to load instantly. So this is actually one of the most powerful features that you can use, and it's not actually very widely used because everyone says, I implemented runtime pre-caching, I passed Lighthouse checks, I have a PWA, I'm happy, but fewer times companies go beyond that point. So the rest of the talk is mostly about ideas on how to improve navigations with service workers. First idea, first strategy we're going to talk about is responding from the cache right away. There are basically two different ways of doing that. If you have static pages, like for example the about page of your site, that's only going to change when you run the build process, you can pre-cache that page, which is the first example. And then, if you have pages that change often, for example, product pages, what you can do is to apply a runtime caching strategy. Could be cache first, or one that I think personally could be better, stale while revalidate. Stale while revalidate is basically you receive a request for a product page. You go to the network. You're going to store this response in the cache. From now on, if the user requests that page again, you can serve from the cache. But you are going to simultaneously update the cache in the background. Second one, which is actually very important, is prefetching. Prefetching is actually anticipating to what the user is going to do next. Have the page already in the cache before the user even clicks on that. Prefetching can be implemented without a service worker with a resource hint. So if you put a tag in the page, link prefetch, article, this is going to be downloaded in the background when the browser is idle, and it's going to be put in a very special browser cache, which is called the Prefetch Cache. It's going to be maintained for 5 minutes. If you combine that with the runtime caching strategy, like the stay while revalidate, what you can do is to extend the lifetime of that resource. So in this example, we are using link prefetch, and we are extending the lifetime of the resource in the cache for 30 days. So before the user clicks on a link, you have it already in the cache, and you can apply a runtime caching strategy for that. This is actually very, very impactful because when the user clicks, 0 time to load the page. Not 0, but well, it's going to be very, very, very quick. eBay, for example, what they are doing is that they are prefetching the first 5 items in a listing page. They say that the probability of these 5 items to be clicked is so high that they can take advantage of the idle time, talk to the service worker, and store these 5 first links in the cache. They do that by default. One more thing, I'm not going to go very quickly into this, but if you are interested on prefetching, take a look at this library, which is called QuickLink. QuickLink is going to encapsulate many best practices around prefetching. So highly recommended. It does things like detecting when a link comes to the viewport and prefetch automatically, and also uses a network information API to only prefetch when the user is navigating in a fast connection type. So this is actually very recommended. Final strategy. These two strategies, you can use the previous one in any site. A site that you have built from scratch or in the site that you are working right now. This is more complicated. So this is only requires an architectural change. And it's about streaming. So how does streaming works? In the diagram in the top, you are seeing a site without streaming. If you are not using streaming, you have to wait for the whole response to arrive before you can start rendering that to the page. But if you use streaming, what you can do, for example, is to wait for a partial part of the page and start painting that part of the page very quickly. Could be the header. So this is the same idea as streaming video, for example. If you are watching a YouTube video, you are not going to download the whole thing. When you start receiving the bytes, you can start showing it to the user. So most sites have this structure. You have a header, you have a content, and you have the footer. And if you navigate to the next page, the part that's likely going to be changed is the content. What you can do in this case is that you can break down this page into 3 different partials. So you can have the header.html, then you can have the content, and then you can have the footer. And the header and the footer can be in the cache. So they can be retrieved immediately, and you can start painting that without the user noticing that. In Warbox, what you can do is to use the extension for streams. You are going to send an array of strategies. So if you receive a request, you break down the request into 3 different requests. One is going to the cache for the header, the other is going to the network for the content, and the other one again to the cache. So as a result, in the old days, in a multi-page app, if you need to move to the next page, you need to wait for the whole request to arrive. In the streaming with service workers world, you only need to wait for the header to arrive to start painting something. So as you might expect, first contentful paint is going to be highly improved by this technique. One final thing, all these strategies, we have a site that's called web.dev at Google. We maintain it with a lot of guides, tutorials, articles, a lot of things. So if you want to go deeper into that, we are going to continue publishing these things to take the most from the service worker. In summary, if you have to start today to build a PWA, first of all, have a plan. Don't reinvent the wheel. Use Warbox or any tool that you can use. And then optimize for both resource navigation requests. Remember that navigation requests are among the most important things. And if it makes sense, explore techniques like prefetching and streaming. Finally, respect the user. You are downloading things that you don't know if the user is going to use. So you don't want to make them pay a lot of cost in advance. So be smarter when you apply any of these strategies. And I think that's it. Yeah.
Fantastic.
Yeah.
Round of applause for Demian, please.
Thank you.
Okay, anyone have any questions? Okay.
Yes, that works in HTTP1. In both. This is transparent because actually the service worker should be a layer that's between the page and the network, but it doesn't have to do with the protocol that you are actually using. The only requirement is that you need to be in HTTPS because of security implications. You have a proxy now, so you can do things like requesting an image of a cat and return an image of a dog, for example. That's a very easy thing, but it's very dangerous. So that's why we enforce to be in HTTPS, but most sites are in HTTPS today. HTTP2 can help on some things, but doesn't have necessarily to do with the strategies that we have seen today. So yes, in HTTP2 you have different ways to architect your site to take the most of it. For example, it doesn't hurt to open several connections, which used to be worse in HTTP1. But that's not necessarily something that have to do with service worker. So service worker is created to be transparent to any kind of protocol that you are going to use. Yeah.
Yeah, I thought those tips were really useful. One thing I'm wondering is there a tool that you would recommend to monitor or measure the performance impacts that you would realize when you implement these kind of techniques?
That's a good point. The truth is that when you implement caching and you are just reinventing the HTTP headers, you have some benefits, but it's harder to realize the benefits in time. One of the things is that the resources that you are going to have in service worker caching are going to be in the cache, likely for longer periods of time, because they are in the top of the priority for the browser, so it's not going to remove them very quickly. A way to visualize that is when you have, for example, real user monitoring data, because you need to see how users are going to come to your site. If you have aggregated data about page loads, you can see in time how many page loads were impacted by that. The Chrome User Experience Report gives you that for free. So if you go to she.com/ChromeUX-, you can see how your site is performing every month, and you can see the percentage of users that are going to perceive your site as fast, according to different metrics. That's real user monitoring. For laboratory testing, today, we have Lighthouse. And the problem with Lighthouse is that it can have some variability in the results. So you can also complement that with web page tests. And another interesting thing, which is probably a broader topic, is how you are going to be able to monitor this in time. So if you can use either the PageSpeed Insights API, which is Lighthouse, or the web page test API, and hook that into your build process, that's definitely going to help. Any other speed tool that you can use, speed curve, whatever. I'm talking about the ones that Google supports, but you don't necessarily need to use them. Yeah. Performance is really hard. You can make an improvement today and then regress in 10 days and be back to the square one. So having these kind of things in place definitely help to maintain performance in time.
One of the things you brought up that I found really interesting was the eBay case study where they prefetched the first 5 listings on the listing page.
Yeah.
And I feel like that would be pretty easy to implement. But then my question would be like, how do you measure, because there's some cost, right, to prefetching too, to make people download them. So how do you measure the cost benefit of it?
That's another good point. I talked about QuickLink. If you use QuickLink, it's only 1 kilobyte. Prefetching is going to be done for every link that comes to the view by default. So if I am scrolling, QuickLink is going to prefetch every link that comes to the view, for example, in a listing. eBay did something that's more complicated because they have a prediction engine. So they use some kind of machine learning to know how likely it is for a user to click on these links. I think this could be over-engineering in most cases. So you could, for example, prefetch only the first 2 links, and that's likely going to impact a lot of your users. If they have to pay a lot for that, don't do it. But something that you can do is to check in which connection type they are navigating. So the Network Information API lets you, for example, only prefetch when you are in 4G or when you are in 3G fast, and not prefetch when you are in 2G and you are consuming expensive data plans for the user. So these are 2 things. Maybe just making a decision of prefetching the first 3 links, that's going to work. You can also use libraries like QuickLink, and also combine it with the Network Information API. This week we are going to release a guide about prefetching in web.dev fast. So if you want to take a look, it's going to include how to do it with adaptive serving, with the Network Information API as well.
Is QuickLink configurable, like do this when you detect this network scenario, or is it just you drop it in and it just works?
So there are different ways of doing that. So let's suppose you generate the listing in the backend and you decide to prefetch only the first 2 links. You can insert 2 link prefetch tags in the page from the backend. And then when you serve the page, these 2 links are going to be prefetched. What happens if you have client-side rendering and you don't know at the moment when you are serving the page which are the items that are going to be shown? Then you wait for the response to come from the listing. You take the first 2 elements, and you can programmatically inject these links in the page. Or what eBay is doing is slightly different. They are communicating with the service worker through a message, which is a post message or could be background sync. Remember that the service worker lives in a different context. So there is a way, a bridge to communicate the page with the service worker and tell, hey, I'm going to send you these 2 URLs. Can you, in the background, cache these 2 URLs? So the prefetching is very flexible. You can do it server-side rendering, client-side rendering is something that you can do. QuickLink, as I was saying, does client-side rendering because it has to detect the links that come to the view. But yeah, you have a lot of options to do that. It's highly configurable.
Cool.
Yeah.
Anyone like the last question?
Thanks for a great presentation. The question is more about Lighthouse. When we see all these case studies of successful PWA sites, and if we look at them with Lighthouse, Lighthouse says they're not PWA. What is it that Lighthouse considers officially to be a PWA?
That's an important point, and I think it's related to another concept as well. So Lighthouse today, if you run Lighthouse from the Audits tab in DevTools, it has the PWA sections that's going to tell you all the checks that you need to pass. If you pass all these checks, you have the badge, which is the green badge. And this is a baseline experience according to Lighthouse. It doesn't mean that if you don't pass all the checks, you are not going to have the PWA, but it's a criteria. What is that used for? Have you heard about, for example, trusted web activities, which is actually you can package your PWA and upload to the store? You need to have the PWA badge to do that, for example. So this is actually, I mean, the concept of PWA is usually pretty broad. It's like a set of modern APIs. According to Lighthouse, all these checks you have to pass to be a PWA. It doesn't mean that you can't add to home screen, you can do other things, but if you want to upload to the store, for example, you need to have the badge. And I have to be honest, the one that's the hardest one to pass is the performance one, which is not related to PWA. It's without the service worker, is your site fast enough in 3G? You have to have a time to interactive below 10, and that's the one that I'm seeing most companies failing. The rest are pretty straightforward usually.
All right, thank you, Demian. What a wonderful presentation. Give it up one more time, everybody.
Thank you.